So good morning.
Good morning, sir.
Good morning, sir.
Okay. So in our last class, we have seen the scope and lifetime of the variable. In case of when we have a function call and we have transferred the control from one function to another. Then this is just a review of the part. So what is happening? If there are two functions, f1 and f2. So f1 is calling the function of f2. Then what happened? F2 cannot modify the variables of f1 because it's the scope and the lifetime of the variables are basically within the scope and lifetime of the variables are within the bound of the function f2. Okay. So how can then the question is that how can we do these things? So is there any way of to get the updation from function to function 2 from the function 1, or do we have any way to update the value of function 1, update the variables of function 1 from the function 2? Okay. So that these things we will understand in this class. So the first thing is that we have to understand that when we are calling a function, so this statement like j is equals to function to I. So in this statement, what we are doing, we are basically calling a function f2, and we are supplying the argument I. We are not supplying the argument I. Rather, we are supplying the value of the argument I to another variable. So if we can understand this concept, the basic concept is that when a function is called, then the function is called with some argument. Then this argument is not basically the variable which has been passed. The argument is basically copying the value of the variables which has passed. Yeah. So let me try to get into this point. So what is happening if we have defined of two functions, like function 1, say it is calling int I equals to 10, then there is an int j equals to 20, then j function 2 I. Okay, so this is one function, and we have another function. We have another function to say int I, where we basically multiply, return, say I. Let we do these things. Int r, say r equals to I into I, and then return I. So these are the two functions. Okay. So if we look into the variables, then this function is having the definitions of the variables like int I, then j. So this I, which is basically for the function C1, this j is for the function 2, 1. Okay. Then this function also defines a variable with the name of I, but for the function 2, and r for the function 2. Okay. Understand? So when the control is within this fu and c1, then the scope and the lifetime of I and j is valid. So they are accessible and they remains into the memory. So when the control goes to this function 2 by a call of function 2I, then what is the implication of the of this call, means how the compiler performs these things. So let me just take this diagram, and now we try to understand the part. So there is a box, or we can say there is a black box for the function 2. So which have opening for the return type. So this is the return, and this is the argument. So these are the, or we can have a figure something like this. This is the argument. Okay. So in this case, if you look into the previous picture, in this case, the argument is I. So this I is now become a local variable for the function 2. So we have a variable of I. So this I is the local variable of func2. Okay, and when this function func1 is having two variables, one is called I and one is called j. Okay, so they are also the local variable for the function. So this is also local variable of func1. So when the call is happening, function 1 I. So what is the meaning of these things? The meaning is on function 2 I. The meaning of this thing is that the value which is stored here, say some value of 10 is stored here. So okay, so this value will be copied to the variable of I, which is the scope, or which is basically associated with the function 2. So this I is not associated with the function 1. So this I is basically associates with the function 2, and the value of this variable is now copied here. Yeah. So it's copying the value of 10. It does not passes the argument. It does not passes the variable to this function. It only passes the value of the variable to this function. Understand? So this is saying to value of the variable I, which is belongs to func1, is copied. Say this is copied at the argument of func2. Clear? Understand? So we just can say this statement is similar func2, which is I, which belongs to the func2. Now this value is copied from the I, which belongs to the func1. Yeah. So this is just a copy of the value. Copy of value. It is not passing it does not pass the memory location or the storage from function 1 to the function 2. It only passes the 1 minute. Okay, so sorry for the disturbance. So the scenario is that the value from the calling function is passed to the called function. So there is a compatible argument. So this argument is also integer. This argument is also integer. Or if there is a compatible integers, like say this is a float, this is an integer. So we can have this type of type conversion, but they should be compatible. So only you have to keep in mind that the variables does not goes from one function to another. The value of the variables goes from one function to another, and the called function, it has its own scope of working variables. It has its own lifetime of the variables. Okay. So in this case, what is happening? Sorry. So in this case, what is happening? The value of 10 is now passed to the variable of I, which is the local variable of function 2. Then it computes I is equals to I into I, and it returns the value to the j. So again, when the return is happening, or when the return is invoked, so that is in function 1, when we have the return. So this is basically the return part. Then again, the value is returned here, not the variable. So not the variable. Here, because the variable does not exist. When it returns from the function, the variables, the lifetime of the variables is no more in the existence. So there is no questions of returning the variables. It only returns the value of the variables. Understand? So so keep in mind that when we are calling a function, we are calling by value. When we are returning from the functions, we are returning by value. We are not calling by the variables, or we are not returning by a variable. Understood? Clear? Is that clear? Okay, then we will take an example. So the simple example to understand the concept is something like this. Say if we want a swap function, say I have two variables in the main. Say I have integer I equals to 10, integer j equals to 20, and we have a swap. We want to swap the variables. We want to swap the value of I and j. So I need a function which swaps, say, I and j. That means after this function calls, I will take the value of 20 and j will take the value of 10. Okay. So a simple implementation one can do is I can write a void swap, say int I, int j. Okay. So there is no ambiguity writing integer I in the main and in the swap, because they are treated as a different variables. Okay. So now I can just take a integer temp. Now temp initially copies the value of I, then I is modified with j, and now j is modified with 10. Clear? Understand? So doing these things, what is the problem? So the problem is that if we just look into this implementation of the swap, so the swap is having two opening, and we don't have any return type. So there is main, where we have I equals to 10, j equals to 20. Here we have the argument I, the argument j. Okay. So now I am calling the swap of I and j. That means I in the first argument I am copying the value of 10 here. Okay. In the second argument I am copying the value of 20 here. Then it swaps the value internally. So now 20 appears in I, 10 appears in I. then it returns. So when it returns, everything is destroyed from the memory. Nothing effect in the main. Main is still I contains the value of 10, j contains the value of 20. Understand? Clear? So what we find? We find that the first question, the first problem that we find from a function or from a called function, we cannot update the variables of calling function. Okay. Understand? Is that clear?
Yes, sir.
So this is called this phenomenon is called the call by value. Call by value is the basic implementation for calling function. So if we just look into the structure of the two functions, one is calling another function, then there is a calling function, there is a called function. So now this is basically the called function. Swap is the called function, and the swap is executed with some arguments. So this is the first argument, argument 1. This is argument 2, and keep in mind that the arguments are not the variables which are coming from the calling function. Okay. So the arguments are containing the value of the variables which are supplied from the calling function. So this is the value is supplied here. The variables are not supplied. The value is supplied. Okay. Understand? So now do we have any mechanism to perform the updation in the calling function? Means the main. So the problem is that do we have any kind of implementation of the swap function? I want to update the variables in the calling functions from called functions. Okay, and then we find that okay, there is a possibility or there is a mechanisms which is called call by value. Okay, call by reference. Call by reference. Clear? So what is the meaning of call by reference? So practically in C programming language, we don't have the concept of call by reference, but still we study the concept because we need a swap function which can update the value at the mean, or we want a function where I can able to update the variables in the calling function. Understand? So instead of writing the swap functions, let me redesign the main in this way. So main is as simple like int say I equals to 10, int j equals to 20, and we have a swap. Okay. So now we redesign the swap in this way. Say this is void swap. So instead of taking the argument as an integer, we are taking the argument as integer pointer. Say IP1 or integer IP2. Okay, and we just redefine the functions in this way. There is an integer temp. So temp is initialized by say star IP1, then star IP1 is IP2, and what do we do? One new
You are muted.
So instead of so if you see the previous call is the swap with the integer values. Okay, so I am calling the swap function with the value of the integers, and then in this case we are calling the swap functions not the value of the integers, rather the address of the integers. Understand? So there is this is the address of I. This is the address of J. Clear? So not the variable, not the value of the I, not the value of the J, but the address of the I and the address of the J. Now what is happening in the swap? So let me take the swap function in this way. So now this is not the integer, this is the address of variable I, say address of some variable J. Okay, and say there are some things that will take care. So in the main memory, what will be the content? So when we are in the main, means in the main memory, this is the memory. So when we are executing the main, so we have created the instance I. So this is the instance I equals to 10. Say this is the instance J equals to 20. And this is the address. Say this may be 5372. This is say 6831. Whatever the part, we just have the address. Okay. So when the call is happen, we are not passing the value of 10 and 20. Rather, we are passing the value of 5372 6831. Understand? So look into this part. So I am passing so these are integer pointers. Okay, so these arguments can hold the address of some integers. So this can also be holding the address of the integer. So now we are passing the value of the address. So we are passing these values to the address. So this is star IP1. This is IP2. And then what is happening in so they are now masked. So they are masked. What is masked? The integer scope, the scope of integer is masked. Clear? So what is now happening? So in the swap, we are basically having a variable which is IP1 and say IP2. And here we are storing 5372 6831. Okay. Now the first statement, what it does? The first statement, it does temp equals to star IP1. So it does, there is a temp. Say let me also have a temp here. So this is temp. So this is equals to star IP1. That means, so the first thing is that we have to resolve what is the IP1. So IP1 is 5371, 5372. Okay. And what is the star of IP? The star of IP is basically the value which is available in this address. So now temp is assigned with the temp. Understand? So now indirectly we are able to access the variable which is available in the main in the scope of main. Clear? So in my previous case, the scope of main is not visible to me. But now, as we are having the address of the variables, indirectly we are able to get access of the scope in the scope of the main. Understand? So what we are doing, we are basically first get the value 5372 as an address. Then we are applying the dereference, and now we get the value of 10. So this gives me the value of 10, and it is assigned to the 10. Understand? Okay. Do you get this point?
Yes, sir.
Yes, sir.
Okay. At the second statement also does similarly. The second statement, what it does. The second statement also does IP1 is equals to star IP2. So what is happening here? So star IP1 is equals to star IP2. So that means this is the this is the IP2. So IP2 is basically 6831. This is the address. And now we have the dereferencing. So this derefers to the item which is stored in the value of 6831. So we get the element 20, and now this 20 is assigned to this part. So again we have a dereferencing of the again we have the value 5372 as address, and now this star IP1 is assigned to the value of 20. So the effect is that what is available in this address is now stored in the address of IP1. So now 10 will be modified with the value of 20. Okay? 20. And the third statement also does in this way. But keep in mind that we are not in the swap. So this is the function of the swap. The swap is not updating the integers. It just get access to the value, to the address, and it operates on the address. Okay, understand? So star IP1 is equals to star IP2. So this statement, like if we take this statement is not an integer operator. So understand? So this is we get the address and we have the dereferencing. We get the address followed by dereference. Okay, understand? So this scope is defined in this area. So the variables in the swap, they are having their scope and length, but the effect is available in the main. Okay. So I am able to access the address. So this address can be accessible in the scope because they are having the lifetime, they are having the scope. So I can do these things, but the effect is reflecting in the main. Understand? So after all, everything is happened, everything is executed, then all the variables are destroyed. So all these variables are destroyed. So there is no existence of IP1, IP2, etc., etc. But what is happened when we execute the swap? It basically updates the variables in the main. Understand? Get it? So this concept is called the call by reference. The call by reference is basically we are not getting the access to the variable itself, but we can get a reference of this address of these variables as the address, and we can call by that address. Understand? So it says that so there is a calling function. So here we have the variables. Okay, so these variables are not accessible from the called function. So they are not accessible. So we cannot get access to these variables. But we have the reference of these things. So that is basically the address. Okay. So they are pointing to these variables. And if I pass this address to the calling functions, then indirectly we are able to update the variables. So if the reference is available, then we can access or we can access the variable. Understand? By the pointer operations like star, IP, in this way. Clear? Okay. So what we find, say in my previous case, if I want to compute the square, means the previous example is that we are intending to have the I square in the value of in the variable of j. So our intention is to find the square of I and store it into the j. Okay? And this is happening by the return statement. As we have the return statement, I can do these things. But I does not updates to 10 to 100. Here I remains 100. J will update from 20 to 100 because J is having the return type. Okay. But in this case, what is happening? In this case, I am passing the passing this argument as a pointer. Clear? So in this case, both I will be updated to 10 into 10, and J will be also modified by the square part of this part. Okay? Understand? So this function, the function to simultaneously updates the value of I to 100, and it returns the value of 100, which is assigned to the variable of J. Okay? So what we have discussed is basically explained in this way. So if I is having the address of 356, and then the function does not contains the value of I, but it basically contains the value of the address of I. Okay? And then we can have a access to the variable by dereferencing operation. Get it? Understand? What is the part? Do you get this point?
Yes, sir.
So whenever we want to keep changes, whenever we want to write a function where the function will update the value of the calling functions, then either you can do these things by a return type, but the constraint is that return type would be a single item, so you cannot return multiple items. So there is a limitations. If you want to do these things by a return type, then you cannot update more than one item. Okay? But if you want to do these things, then the elements which has to be updated, we have to provide the reference of that variables, okay, to the function. Okay, so say there is a function fun1, and we have some variables, say x, y, and z. So I want to update those three variables from a called function. Okay, so what I can do, I can assign one of the variables with a return, say fun2, one of the return, but I have to provide the reference of these two variables. So I have to provide the reference of x and the reference of y, or the address of x and the address of y to the function, such that it can also have a indirect access to the variables. Okay, so this indirect access is basically to the address. Okay, understand? So, okay. So in this case, we are basically passing the reference. Reference is terms of the address. We are not passing the value of 10 in the function 2. Rather, we are basically passing the address of the variable I to the function 2. Understand? And then it is easy to get access of the variable from the called function. So this is all about the function. So what we have studied in the function are so this is function in C. So this is firstly, this is the modular programming. So we can partition my problem into small problems. Then we independently solve the small problems, and we integrate the result to get the final output. So this is a modular programming. Okay. Then we have function prototype and definition. Then we define the arguments and return them. And then we have scope and lifetime. Then we have the control. Before that we have control flow. And finally, we define the call by value and call by reference. So this call by reference is, in purely speaking, this call by reference is not available in C. So this is not in C, but we can simulate, we can get the effect. We can get the effect by the reference, using pointer. Okay. So everything that we have seen in C programming language is called by value. So if we move backward, then we are also finding that this is again a call by value. So this value is copied. This value is copied. It never passes the variable of the integer address. It only passes the value of this integer, value of this address to the variables. It also only passes the value of this address to the variables. It does not passes any variables from the calling function to the call function. Every time it passes only the values. Okay. But at the same time, we have the effect of call by reference, because if I get the address, I can also fetch the variables by having the dereference. So that is all about the function. So what is the time? Okay, we can stop for today. So this is Monday. Tuesday we will have a session on the recursion. Recursion is basically when we call the function, when we call the same functions multiple times. Like if I want to write a function like say we are writing a series, say f of n, like 1 plus 2 plus 3 plus 4 plus something, some value of n. So this can be written in the form of n plus f n plus minus 1, and then this can also be written in n minus 1 plus f n minus 2. So we are basically executing the same function, the same property of the function with different arguments. So this type of, how can I do these things? How can I invoke the same function from the body of the function? Yeah. And this is called this term is known as the recursion. So doing recursion, we have a great advantage to solve different types of problems. So we'll study little about recursion, and that will be the end of this course. Okay. Okay. So reward keywords.
সেটা বুঝিনি স্যার, যদি একটু বুঝিয়ে দিতেন।
Scan if percentage of the topic code দিয়েছে, but percentage I am not sure. You have to check it. And this percentage of C টাও করতে হবে, star C. I have to check of these things. Okay, I am not sure, but percentage of ampersand, no, percentage of slash n is basically we want to scan the new line character itself. Then we can do this specify.
এটাতে স্যার মানে একটা কিওয়ার্ড নিচ্ছে, স্পেস পর্যন্ত নিয়ে নিচ্ছে অ্যাডের।
Means white space, if we have some white space, then we can also include this white space in the scanf function. Understand? What happens if we have a white space and just like Joydeep, then blank, then Howlagar, or Joydeep tab Howlagar, then scanf function only reads the Joydeep. So any white space, which white space is basically called a blank, tab, and enter, they are all treated as a end of the string. Understand? So this option is you may heard about the wild character. Wild character, say if you search for directory star, means this is basically a wild character which matches every possible strings. So these are basically the wild character. So it reads, I think, is the single one instance of say white character, means one instance of white character. Okay. I'm not
Okay,
sure.
sir.
Means, so this is the single instance. So this stands for the one instance. Okay. Understand?
Yes, sir.
And star stands for multiple, any instance. This stands for any instance. Okay. So then I have to check this for how it is happening. This is a little bit of tricky part. Okay.
Okay,
Let
sir.
me stop the. Any other doubts? Okay. So we can stop the class for today, and next Tuesday we'll meet in the morning. Thank you.
Okay, sir.
Thank you, sir.
Thank you, sir.
Thank you.
Thank you, sir.